So today, let's talk about something called the atomic kernel. It's a system that's been designed from the ground up to tackle a huge problem in our digital world. How can we actually prove that the information we're looking at is real? It sounds like a simple question, but think about it. Every single day, we look at bank balances, messages, documents, and we basically just have to assume it's all correct. But what if we didn't have to assume? What if we could actually prove it? And that right there is the huge shift in thinking. See, most systems, they just kind of ask you to trust them, right? Trust the server, trust the app, trust the company. The atomic kernel does something totally different. It's built on the idea that you, or any part of the system, can independently verify that the data is correct and that its history is totally clean. Okay, so how on earth does it actually pull this off? Well, it all starts with a really powerful idea: radical absolute organization. Well, think about it. You can't really verify chaos, can you? To prove anything about data, every person and every machine involved has to be speaking the exact same language. You absolutely have to have a shared, standardized structure. So this standardized structure is called a shared control plane. Probably the best way to think of it is like a universal blueprint for information. It's a set of really strict grammar rules for how data gets put together, making sure every little piece of info has a clear, unmistakable address. And how it does this is, well, it's surprisingly simple and kind of brilliant. It doesn't use some fancy new technology. Nope. It actually uses a set of universal, non-printable control characters that are already baked into computing standards like ASCII and Unicode. You're looking at them right there. FS, GS, RS, and US. They stand for file, group, record, and unit separator. And because they're so fundamental, they act like these invisible, unchangeable punctuation marks that create a rock-solid structure for all the data. Every part of the system can understand it perfectly, no ambiguity. All right, so once all the data is neatly organized and speaking the same language, what's next? The next step is building a system of enforcement. And the atomic kernel does this with a really strict hierarchy, something it calls an authority ladder. And this is the golden rule, the one rule to rule them all. Power only flows one way, down. The foundational laws set the rules, and every single layer built on top has to obey them. No exceptions, no backdoors, no admin overrides, period. So let's take a look at this ladder. At the very bottom, you've got the kernel. This is like the Constitution, the unchangeable law of the system. One step up, you have extensions. Think of these as proposed new features. Then comes the advisory layer, which just offers guidance. And way up at the top, you have the projection. Now, this is what you, the user, actually see. And it is strictly a read-only view. It has zero power to change the truth underneath. Okay, let's dive deeper into that foundation, the kernel. What makes its laws so, well, unbreakable? The answer is pure math. You see, the kernel is built on this core principle called determinism. And it's actually a really simple idea. It's like a perfect recipe. If you follow the instructions and use the exact same ingredients every time, you are guaranteed to get the exact same cake, every single time. It doesn't matter who's baking or what kitchen they're in. The result is always the same. And this isn't just them saying, hey, trust us, it's deterministic. No way. The core laws of the system have been formally proven using a tool called Coq. You can think of it as a super-powered, inhuman math checker that goes through the logic and verifies that it is absolutely mathematically correct. And this formula, this is it. This is the heart of the whole thing. Now, you don't need to be a cryptographer to get what this means. This is the law. This is the mathematical operation that gets proven. It's a single, unchangeable formula that acts as the ultimate source of truth. Any valid change to any piece of data in the entire system has to be a direct result of this exact calculation. So, okay, we've got this perfect, mathematically proven law at the center of everything. But how does the system actually enforce it day to day and make sure it stays honest? It uses something called the Verification Triad. It's a three-pronged approach to keeping everything honest. First, you have the proofs. That's the mathematical contract, the Constitution we just saw. Then you have the gates. Think of these like the police, constantly running checks to make sure no laws are being broken. And finally, you have replay locks, which are like cryptographic fingerprints of an item's entire history, proving it was created exactly according to the rules. And when you put these three things together, they're designed to stop all those nightmare scenarios you hear about in complex systems. Things like data just drifting out of sync between two different computers, or someone creating a fake identity, or tampering with the history of a transaction. It's designed to stop all of it. Okay, so let's pull back for a second and look at the big picture. What makes this whole approach so fundamentally different?
There's a common way of building systems called event sourcing, and it's all about just recording what happened. The atomic kernel does that too, but then it adds the most important step. It gives you the tools to prove that the recorded history is legit, using those gates and replay locks. It's really the difference between writing in a diary and signing a notarized legal document.
And it's also super important to be clear. This is not a blockchain. Blockchains are incredible pieces of technology, but they're built to solve a different problem, getting a huge group of anonymous strangers to agree on something. The atomic kernel is designed to solve the correctness problem inside a known system. It's for proving computation, not for building economic consensus.
So really, if you remember one thing, it's this. The entire point of this architecture is to get away from the just trust me model. It replaces that fragile idea of trust with something much, much stronger. The ability for anyone or any machine to independently verify the truth for themselves.
And that kind of brings us to a really big question, especially right now. As our digital world gets more and more crowded with convincing AI fakes and manipulated content, what is the real value of a system that can give us a mathematically verifiable source of truth? It's definitely something to think about.